Thousands of buses run empty every hour alongside thousands of cars on the road. Commuters miss last mile feeder buses because of delayed trains and arbitrary bus timetables. The lack of appropriate public transport amenities in outer suburbs prevent many of the more vulnerable from accessing vital services in their community. To solve these problems, we introduced Digital Transit Twin. DTT aims to create an on-demand public transport network that runs to customer schedules to serve currently underserviced regions. Customers can book buses from anywhere that arrive within minutes. A digital replica of each customer is then crafted using tools such as location history and travel preferences. Simulations carried out with the digital twin allow movement prediction and automated pre-booking of services. Welcome to the future of transport. Our challenge statement was, how might we create a digital twin of a commuter to provide demand-responsive transit to scale up provision of services in regions that are underserviced by public transport? This was born from interview and desktop research, which indicated that outer regions generally have poorer public transport access. Commuters often opted for private car travel, which builds up congestion and lowers demand for public transport. This, in turn, lowers service frequency. It is the most disadvantaged, such as the elderly, the young, and the low income, who experience the worst effects of cuts to services. To introduce our app, we'll walk through a day in the life of Elizabeth Hepburn, a university student with accessibility needs. Elizabeth starts her day by checking her notifications. She sees that her regular morning route is experiencing a disruption due to signaling faults. Elizabeth needs to get to her university lecture in time, so she approves of a reroute to the next closest line, Upfield. She'll arrive a few minutes later than anticipated, but won't otherwise be heavily delayed. While Elizabeth is on the feeder bus, she decides to check out her digital twin profile to make updates. She looks at her overview and is assured that her disability is not recorded in plain text in the application, protecting her medical confidentiality. She then makes quick manual updates to her personal information and lets the simulations run in the background. Elizabeth gets home later in the afternoon. After getting ready, she makes an instant booking to the National Gallery of Victoria, where she is meeting her friends for the NGV Friday night events. She strolls over to the bus stop and waits only a few minutes for her bus to arrive. Following user evaluation testing, the application has been streamlined with improvements. Elizabeth can now make bookings in advance by choosing the date and time first, rather than choosing the route first. This has made the option more visible and appealing to her. DTT now also optimizes Elizabeth's digital calendar entries. If she makes an appointment that the digital twin calculates would be impossible for her to arrive to on time, she will be alerted. User interface improvements include changes to the calendar interface and menu options for the booking page. Dense information under the human digital twin data have been compartmentalized under slide-out menus. Other minor changes were made to improve the readability and intuitiveness of the application. To conclude, our technology capitalizes on existing demand-responsive infrastructure. Trials have already commenced using on-demand transport in cities around the world with incredible reception. Our next steps will be creating and perfecting the human digital twin technology that will enable these interactions. In the far-off future, we hope to further optimize the technology with self-driving fleets to create around-the-clock, cost-efficient, and reliable public transport for all.